All right, so today we're going to do estimating percents using the 10% method. And this is the method that most of your parents use. They may not know that we call it the 10% method, but if you asked your parents to estimate something with percents, this is probably what they would do. And they would usually do a lot of it in their head. Solve the proportions below to find 10% of 506. Then try 10% of 96.5. So if we start off our proportion 100 times x equals 506 times 10, we would know that 506 times 10 is 5,060. We would divide both sides by 100, and we would get x equals 50.6. So what we want you to notice is that 10% of 506 is 50.6. All right, so let's look at the second one. If we do cross products again and we do 100 times x equals 96.5 times 10, what happens, right, when you multiply by 10 is you just move that decimal point over one place. So we have really 100x equals 965. And then we would divide both sides by 100, and we would get x equals 9.65. So 10% of 96.5 came out to be 9.65. So what do you notice when you find 10% of a number? 10% of 506 was 50.6. 10% of 96.5 was 9.65. So to find 10% of a number, move the decimal point one place to the left. For example, 10% of, let's say, 32 is 3.2. And that's really all we're saying here is that if you want to find 10% of a number, you don't have to do all of the proportion work. You can simply move the decimal point one place to the left. So now we're going to use what we know about finding 10% to estimate, right? So instead of 21%, we might only say, oh, well, what's really close to 21%? Well, close to 21% is about 20% of 90. So I might say, okay, well, if I want to find 10%, I'm going to start, right? 10% of 90 is 9. So 20% would just be double that, would be 18. So 21% of 90 is about 18. That's really what we can do. We can use the 10% of a number in order to find other percentages. Now, we only found 20%. And we wanted 21%. So we know that it's about 18, but our answer 18 is a little bit low, right? Because we only went with 20% instead of 21. So we might say a little more than 18. Okay, we can be a little bit more specific sometimes. So the next one is what's 39% of 452? So 49% really close, 39% really close to 40%. And 452 is not particularly friendly to work with, so I'm going to use 450. We like things that end with zeros because they're really easy to take 10% of. So I might say, what's 10% of 450? If I move my decimal point over one place, that would be 45. Well, how do I find 40%? I would say to multiply it by 4, and the same thing with the 45, which would be 180. So we can say that our answer is about 180. Now, the thing we wouldn't do in this case, we wouldn't try to do a little more, a little less, because we actually rounded both of the numbers. We rounded the percent up, we rounded the 452 down. So we would just want to say about 180. So the first one, we might be able to give a slightly more specific answer. The second one, about, is going to have to be good enough. What is 81.6% of 737? So we might say that that's really close to 80%. And 737, we might go with 740, right? This is all about estimating. And estimating should be something that we can do very quickly and easily, no calculator. So we want to use numbers that are quick and easy and friendly. So 10% of 740 would be 74. So if we want 80%, we could multiply that by 8. and say that 80% is about, and I'm saying about because I rounded the original ones, but it's about 592. I'm actually doing, 74 times 8, 56, 57, 58, 59. Like I actually did 74 times 8 and got 592. But the reason I'm using about, again, I will use it in my answer. I had rounded the numbers from the original question. Last but not least, how do we find something over 100%? Well, first I'm going to start by just doing the 21. Okay. This, we're going to go with 120 as being really close to 121. But I'm going to start by saying 10% is 32 if I just move my decimal point over one place. 20%, if we doubled that, would be 64. So how do we find 120%? Well, 100% of the number was the original number, 320. We want to add in an extra 20%, which would be adding in an extra 64. That would give us the 120% we were looking for, which is 384. So we could say about 384 as our final answer because we have 100% of the original number plus the extra 20%. You'll also notice that our original number is 320. Since we wanted a percent over 100%, our final answer was higher than 320, which is exactly what we would expect. Last but not least, at a restaurant, the bill comes to $43.89. You typically leave a 20% tip for exceptional service. Estimate the amount of the tip, then find the total amount of the meal, including the tip. So I'm just going to pretend that this is a $44 meal because $43.89 is not really friendly. I'm going to say that 10% would be $4.40. So 20% would be $8.80. So I might leave a tip of $8.80. Now, depending on the person, you might do this differently. You might just say, I'm going to say $9. It was really good. I don't want to deal with the change. So you might go with $8.80. You might go with $9 for the tip. Either one is fine. You have the original $43.89. You have to add in the tip. So if you wanted to add in that $8.80 tip, you would pay a grand total of $52.69. So I would leave $52.69. That would cover my meal and it would cover the tip. I am assuming that tax had already been taken care of in there, but if we needed to, we could do tax as well. Depending on the state, different percentages for tax. If you wanted to do the $9, you also could have said $43.89 and just added $9. You also could have said, I don't want to deal with change at all and do $44 plus $9 and just leave dollar bills or just pay an amount that didn't have change. So we can also find things that are multiples of 5. Okay, so on the back, it says you can shift a decimal point one place to estimate 10%. You can use half of that in order to estimate 5%. So we don't have to just do 10s, 20s, 30s. We can do 5, 10, 15, 20, 25, 30, and so on. Now I have 2 sample questions up at the top you can refer back to at any time. All the steps are written out. We're going to do 4 of them together. Use what you know about finding 10% and 5% to estimate the following. So 23%, the closest friendly percent to that is 25%. And so I'm going to go with 25%. And I'm also going to think about that 76, right? I might go with something like 75 just because it's a little friendlier to work with. So I'm going to say, well, what's 10%? 7.5. What's 20%? If I double that, it's 15. Well, what if I tried to go backward and say, well, what's 5%? What's half of the 7.5? Or what's half of the 10%? And that would be 3.75. So I might add together the 20% number, which was 15, and the 5% number, which was 3.75. And there would be my 25% at 1875. Now, for those people who want to argue this should be easy, you might have even gone up to 80 instead of 76. Okay, well, that would mean 10% would be 8, 20% would be 16, If I only want 5%, that's half of my 10% number 8, which would be 4. And if I add my 20% and my 5%, 25% using this way came out to 20. Not terribly different than 1875. A little bit friendlier though, right? Less work with decimals. So again, when it's estimating, as long as you're using a strategy that's consistent, you can round to numbers that are close by that are friendlier. All right, what is 16% of 80.4? So we can probably see that instead of 16, we're going to go with 15. And instead of 80.4, let's make our lives easier and go with that nice 80. So 10% of 80, if I move my decimal point over one place, is 8. Half of that, 5%, would be 4. And if I add them together, I would get 15%, which is 12. So that's not terrible. The first one, we might say about 18.75. If you went with the other method, you might say about 20. On this one, we would say about 12. So not forgetting that our final answer is an estimate, even though we did an awful lot of math to get it. What is 74% of 19? So I'm going to go with 75%. And instead of 19, I'm going to use 20, which is a whole lot friendlier. 10% of 20 is 2. If I think about my half right away, 5%, because I'm going to need that eventually, is 1. And if I multiply by 7, I can get 70% is 14. So if I want to combine my 70% number 14 and my 5% number 1, 75% is going to be 15. Now, some of you might remember from a previous lesson that 75% is the same fraction as 3/4. We could do 3/4 of 20 or 3/4 times 20 just for the heck of it, and notice that we would still get that same estimate of 15. So whether you're using the new 10% method or you really liked the friendly fraction method, they should be coming out with very similar results. In this case, about 15. Last but not least, what about those percents over 100? Well, if I want to sort of stick this off to the side, I know that 100% is that 44, that original number. I don't have to wait until the end to remember to write that down. Sometimes that's helpful. What about 50%? Could I maybe find 50% easily? What's half? 50% of 44 would be 22. So I could add in 50%. And then what about 5%? So a couple different ways to get this. Some people move it over and say, well, if 50% is 22, then 5% is 2.2. And they just move their decimal point one place. Other people say, 10% is 4.4. So 5% is half of that 2.2. Whichever way your brain works, you still need another 5% to get close to 155%. And notice how I set these up. So I have like my decimal points lined up when I add them. I'm going to have 155%, which is 68.2, or I can say about 68.2 using the 10% method. So basically, to wrap it up, 10% is where you move your decimal point over one place so you can find 10% of a number. And then from there, you can find any percentage that is a multiple of 5 or a multiple of 10 and estimate your answer without needing the percent proportion.